Hello children, so welcome to AIMS India's online classes. Today from mathematics subject, playing with the numbers topic we are going to continue. So in our previous videos, we learnt about HCF, highest common factor, LCM, least common multiple. About these two terms we have learnt already. HCF is also called as GCD, greatest common divisor. So how to find HCF for HCF of two or more numbers or LCM of two or more numbers? About that concept already we have discussed. So our today's concept is a relation between HCF and LCM of two natural numbers. So we are going to find the relation between the HCF and between the LCM of two given natural numbers in this video. So here, so the relation is the product of HCF and LCM of two natural numbers is always equal to the product of given numbers. Means if the given numbers are 30 and 48, what we have to do? We have to do prime factorization. Of the given numbers. What is prime factorization? Writing the given number as a product of its prime numbers is called prime factorization. Okay. Like that for 30, we have to do prime factorization. For 48, we have to do prime factorization. We will get some prime factors. Now, what is HCF? HCF is the common prime factor, least number of times, how many times it is occurring, that we have to take. Here, highest common factor. The word opposite to highest is least. So for finding HCF, we have to take the common prime factor which is occurring least number of times. 2 one time, 2 4 times. Least means 1 time. 3 1 time, 3 1 time. Least means 1 time. 5 1 time, 5 0 times. Least means 5 0 times. We won't take 5. So that prime factor least number of times, after taking that, we have to multiply them. 2 3 is 6. So the HCF of 30 and 48. The HCF of 30 and 48 is 6. In the same way, LCM, least common multiple. So what is the opposite to least? Greatest or highest. While calculating LCM, we have to consider the prime factor, common prime factor, which is occurring greatest number of times. Here 2 1 time, here 2 4 times. So greatest number of times, 4 times we have to take. Here 3 1 time, 1 time. Greatest number of times, 1 time. 5 1 time, 0 time. Greatest number of times, 1 time. We have to write all the factors greatest number of times and we have to multiply them. So then we are getting 240, which is the LCM of 30 and 48. So with the help of prime factorization, for the given two numbers, we have calculated HCF, it is 6. We have calculated LCM, it is 240. Now, what is the relation between them? The product of HCF and LCM means HCF is 6, LCM is 240. The product of these two, 6 into 240, equal to product of given two natural numbers. What are given numbers here? 30 and 48. So it is equal to product of 30 and 48. 6 into 240, 1440. 30 into 48, 1440. So the relation, this relation is true. So the product of HCF and LCM of given two numbers is always equal to product of given numbers. So like this we can relate the two numbers and their HCF and LCM. Okay. Next. Suppose just now we have learned that LCM into HCF. LCM into HCF equal to their product. It is equal to their product. If you want to find only LCM, so this HCF will come down. So product by HCF. Product by HCF. Like that we can write. Or if you want to find HCF, so LCM will come down. LCM will come down. We can write it as product by LCM. Product by LCM, like that we can write. So LCM means product by HCF. HCF means product by LCM. Like that we can calculate. Or if you want to find one number, so product of HCF and LCM by one number equal to other number. We will get another number. Okay. We will get another number. Or if two natural numbers are co-prime numbers, if two natural numbers are co-prime numbers, then their LCM equal to product of the numbers. Because 3 and 5, two numbers are there. 3 and 5, we have two numbers. What is their HCF? 3, 5. 3, 1 is 3. 2, 3. 2, 1 is 2. 1, 2. So 1, 2 times 2, 0. So if given two numbers are co-prime numbers, then their HCF will always be 1. For two co-prime numbers, the common prime factor will be always 1. That's why they are called co-primes. So we are taking co-prime means they don't have other common factor other than 1. So their HCF is 1. So then what is the formula? HCF into LCM. HCF into LCM equal to product. HCF into LCM equal to product. But for co-prime, HCF is always 1. So no need to count this HCF. So LCM equal to product. LCM equal to product. So if they are co-primes, LCM is equal to product of the numbers. Product of the numbers. So the LCM of any two natural numbers always divisible by their HCF. Here we have HCF 60, LCM 240. So this 240 is divisible by 6. Means the LCM is always divisible by HCF. It is always divisible by HCF. Or HCF is a factor of LCM. Okay, sir. Next is the example question. The HCF and LCM of two numbers 6 and 840 respectively. 1 minute, sir. So the HCF and LCM of two numbers, one is 6, another is 840 respectively. They have not given the numbers, but their HCF is 6, LCM is 80 respectively, like that they have given. One of the number is 42. Then what is the other number? They have given HCF equal to 6, LCM equal to 840. One of the numbers is 42. According to the relation, what we know? Product of LCM and HCF equal to product of numbers. LCM is 6, HCF is 840. 840 into 6 equal to, what is the product of numbers? One is 42, other is, we don't know, we have to find. We are writing other number here. Then what is the value of other number? This 42 will come down. 840 into 6 by 42. 840 into 6 by 42. Okay. 840 into 6 by 42. 6 7 times. 6 7 times 42. 7 1 is 7. 7 2 times 0. 120. So direct answer how much? 120. So other number is 120. Hence the other number is 120 here. Next. Find the HCF of 198 and 78. Find their LCM. First we have to find the HCF, and with the help of HCF we have to find the LCM. These two are the given numbers. So how to find HCF of given numbers? The biggest number will become dividend, smallest number will become divisor. So 78 2 times 156, 42 remainder. Now this divisor will become dividend. 42 1 times 42, 36 remainder. Now this divisor will become dividend. 36 1 times 36, 6 remaining. This 36 will become dividend. 6 times 36 0. Means when we are dividing with 6, the remainder is 0. So that's why 6 is the HCF. 6 is the HCF. So after finding HCF, how to find LCM? So how to find LCM? Product of numbers by HCF. So 198 into 78 by 6. 6 13 times 78. So 198 into 13, 2574. This is the answer. In this way, first we have to find HCF. Then with the help of HCF and numbers, we can find the LCM. Next. Can two numbers have 12 as their HCF, 234 as their LCM? Give reason and justify your answer. Justify your answer. Justify your answer. So here they have given 12 as their HCF, 234 as their LCM. Let's divide LCM with HCF. With 12, 234, if we divide means 12 1 is 12, 11 remainder, 4 we will take down. 12 9 times 108, 6 is the remainder. So on dividing 234 by 12, we are getting 19 as quotient, 6 as remainder. 6 as remainder means the remainder is not equal to 0, or 234 is not exactly divisible by 12. Means LCM is not divisible by HCF. It is wrong, because LCM is always divisible by HCF for the given two numbers. If it is not divisible, means they are not the HCF and LCM of given two numbers. Okay, because the LCM is not exactly divisible by the HCF. So for the two numbers, these two values will not be the HCF and LCM, because LCM always exactly divisible by HCF. That also we can prove. Next one. Okay, children, this is the relation between HCF and LCM. HCF and LCM. Okay. Now let's see some blanks here. Blanks, children. The only natural number which has exactly only one factor. So what is the natural number which is having only one factor, exactly one factor? 1. The answer is 1. Okay. The only prime number which is even. The only prime number which is even. The only prime number which is even. What is the only prime number which is even? Because the prime number starts from 2, 2, 3, 5, 7 and so on. So the only prime number which is even means it is nothing but 2. nothing but 2. The HCF of two co-prime numbers. Why they are co-prime? Because they have common factor only 1. So their HCF is 1. One minute, children. One minute, children. Hello? Hello, children. Is my voice audible? Hello? Okay. 1 minute. Hello? Hello? Okay. Okay, children. Next. Fourth question. Two perfect numbers are. Suppose if we take number 6. If we take number 6. What are the factors of number 6? 1 is a factor. 2 is a factor. 3 is a factor. 6 is a factor. The sum of all the factors excluding itself. Sum of all the factors excluding itself is how much? 1 plus 2 plus 3. How much? 6. If the sum of all factors excluding itself is equal to the same number, then it is called as a perfect number. So here one number like that is 6. In the same way, this one, do it as a homework, children. Try to find other number which is a perfect number. So what is the perfect number here, children? What is the perfect number? The sum of all its factors is excluding itself. Excluding itself, if it is equal to the same number, that is called as a perfect number. Okay, like that one number is 6. Another number, you try to do it as a homework, children. So next, the only prime triplet. They are asking about prime triplet. So actually in lesson we have not come across this concept, prime triplet. Prime triplet here. Okay, let's see the concept tomorrow, children, because this concept is not covered. Okay, next. State whether the following statements are true or false. True or false. So every natural number has a finite number of factors. Yes, factors are always finite because the factors of any number less than or equal to the same number. Factors are any number or less than or equal to the same number. So that's why they are finite. True. So every natural number has a infinite number of its multiples. Yes, true. Because multiples, if we go on multiplying with all natural numbers, multiples will be coming. There is no end to the multiples. So they are infinite. True. There are infinitely many prime numbers. That is also true. infinitely many prime numbers also true. Next, if two numbers are separately divisible by a number, then their difference also divisible by that number. Divisible by that number. Suppose let's take 6 is divisible by 2. 2 3 times 6. Another number, if two numbers are separately divisible by a number, or let's take with the help of 3 actually, let's take one odd number, 3 2 times 6. 6 is divisible by 3. In the same way, 15 is divisible by 3. 3 5 times 15. Now what you are asking, their difference. So one number is 6, another number is 15. What is the difference? 15 minus 6, how much? 9. This 9 also divisible by 3. 3 3 times 9. It's okay. True. True. Next, LCM of two prime numbers equals to their product. LCM of two prime numbers equal to their product. Wrong. Because LCM of co-prime numbers equal to their product, it is true. LCM of all prime numbers, it is not equal to its product. This is wrong. Okay. This is true. A natural number and its successor are always co-prime. A natural number and its successor are always co-prime. So if you take any number, 81 and 82, successor, or 5, 6, what is common? Only one is common between two successive numbers, or 21, 22. What is common? One is odd number, one is even number. Even number means divisible by 2. Odd number means not divisible by 2. Means they are divisible by only by 1, not by 2. If it is by 3, this is not by 3. So, a natural number and its successor always co-prime. True. So, okay children. So, this all problems are there, but in tomorrow we are going to learn the previous Olympiad worksheet questions. In that we can cover these questions. Okay. So that's all for today. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.